In this video, I'll be going over the solution to the 2024 AMC 10A problem 25. So here we have a diagram of toothpicks, and basically we have to create a closed loop that does not intersect itself, and out of these toothpicks, and we can't have like any of these squares having more than one toothpick attached to them. So like this would violate our condition because two of the sides of this square have toothpicks on them. We can only have one. So for this problem, we can just do casework. So first of all, by default, we have two loops. I can either do a loop like this, where I just put toothpicks along this rectangle, or I can have a loop here, where I put toothpicks along this rectangle. So that gives me a total of two loops. Right. So two loops. And then for the first case, assume that we have toothpicks here and here. And then assume that we assume we go like this, right? Because we already have a toothpick here, so we can't cover it. So if we have a loop like this, then how many loops can we create in this scenario? So for each of these squares, notice how I can either go here and continue on, or I can just move up and avoid it completely. So I have two possible situations for this cell, because I can either just go on, or I can move down, and then 2 for this one, 2 for this one, 2 for this one, 2 for this one, and 2 for this one. And so that gives us a total of 2 to the power of 6 ways if we have toothpicks here and here. Okay, so that's the first case, and now let's do the second case. So our second case is if we have toothpicks in the middle, like that. And then we have to have our loop going like this. Okay, so same situation. We just have two choices in each of those cells. So 2 to the 4. Remember, this is just because for each cell, we can either go and cover the square with toothpicks, or we can just like stay on top and avoid it. Because it says a maximum of 1. And if we stay on top and avoid it, then we have to come back down and cover it. So we're basically doing a complement move, right? If I do this, then when I come back down here, I have to avoid it because it has to have 1 toothpick. It can't have 2, and it can't have 0. So yeah, that's kind of the logic behind this whole thing. And then if I have a toothpick here and then another one in the middle, then my loop goes like that. And then I have 2, 2, 2, 2, 2, so 2 to the power of 5. And then I can do the same thing, and I have to multiply this by 2 because we can also have this case where I have a toothpick here and another one here, and then the loop would just look like that. And so in total, we have, in total we have 2 plus 2 to the power of 6 plus 2 to the power of 4 plus 2 to the power of 6. This is equal to 64 times 2 plus 18, and that equals 146. And so C is our answer.